I'm Jeff Marion. I work with the U.S. Geological Survey, formerly with the National Park Service, and I'm a recreation ecologist. I'll present a little bit about that in just a few minutes. But it's my pleasure to be with you today. As Jimmy said, we'll be talking about the sort of the sustainable camping and trail management toolbox. And let's go ahead and just get started. I've got a slide here with my objectives for today's talk. The first is to just simply talk about the challenge of sustainably managing campsite and trail impacts. You know, how do we do that? We need to do that. Our visitation has been increasing for years now. Introduce recreation ecology science. It's a very small field of study. There's just a few practitioners in the United States, of which I've been one for about 4 decades now. I'm nearing my retirement. But we'll talk about some relevant implications from recreation ecology research for managing, again, trails and campsites. And then I think many of you are probably familiar with the visitor use management framework or decision-making process. We'll talk about that very briefly and talk about sort of sustainable best management practices or BMPs, again, for campsites and trails. So our challenge today is really wilderness, the increasing use of wilderness, and you know, how do we sort of finesse that dual mandate of, you know, preserving these naturally functioning conditions and ecosystems for, you know, present and future generations, but also to do it in a way that leaves them unimpaired. And so we're trying to avoid or minimize the impacts associated with visitation to wilderness, to backcountry, to parks, forests, preserves of all types. And so how do we make that visitation more sustainable? That's really the key word. And science can help. You know, super knowledgeable and experienced managers can help. But I've always felt like the best decisions, the optimal decisions, are made when you combine those two things, and when you have dialogue with visitors as well. So I mentioned this visitor use management framework. My own depiction of that is on the right side here. But you know, the definition of visitor use management is the proactive and adaptive, it's sort of an adaptive management process for managing characteristics of visitor use. That's like the amount of use, type of use, user behavior, but also a host of environmental attributes and managerial attributes. Like managers would be, how do we manage the camping? And environment would be, you know, vegetation types or soil types and topography, those sorts of management, sort of site management actions. But how do we manage all of those things to achieve our desired conditions? And those conditions can be resource conditions, like the condition of our trails and campsites, or they can be experiential conditions, you know, like is there solitude, for example, or natural quiet. And so it begins by defining those desired conditions you're trying to achieve. You then choose some indicators of change. You set standards or thresholds for those indicators that describe the point at which conditions become unacceptable to managers. You then go out and do monitoring, and you compare conditions to those desired future conditions or those standards, those thresholds. And when the thresholds are exceeded, that means you've got a problem. You've got some unacceptable conditions that have to be managed. And that's what we're going to be talking about today, are the tools for managing those unacceptable conditions. You implement those tools, and then, as I mentioned before, adaptive management, you see how well they worked. And you do that by periodically monitoring those conditions again, maybe every 4 years, maybe every 10 years. But at some period, you go and monitor conditions again, compare to standards, and see if your actions worked or not. If they did, great, buy yourself a beer. If they didn't, then, you know, turn around and implement some new actions, you know, based on what worked or didn't work last time. You select new actions, implement those. So it's an ongoing adaptive management process. And what we're going to talk about today are the tools that you would apply in that process. And they're derived, at least from my perspective, from recreation ecology, which is a very small field of study that evaluates what are these impacts that we're talking about out there. So we describe those impacts, we measure them, and monitor them. But then we do analytical work. We do statistical modeling, like multiple regression work and other multivariate statistical analyses to try to understand what are the influential factors that affect the severity of that change, whether it's soil loss on trails or size of campsites or any number of other indicators. We're trying to understand and model the impact process, the degradation that's going on. And from that knowledge, we then work with managers to suggest what we think would be effective tools to apply. And so we reach into our toolbox and we might be manipulating use-related factors like type and amount of use or user behavior. We might be manipulating the infrastructure, the trails and the campsites and their locations, their alignments. Or we might be manipulating other aspects through education, like leave no trace, or regulation, like, you can't camp here, you can camp here, or horses aren't allowed on this trail, those sorts of things. And so that's how the science works. We measure things. One of the most common important things that we measure would be campsite size. And here's a young woman who's defined the boundaries of this campsite. It's in the Boundary Water Canoe Area Wilderness, where I did my doctoral work. And we measure the size of that campsite and then try to understand, why is this site fairly small and other sites are quite large. And so that's how recreation ecology works. We go out and we measure things, and then we do relational analyses to understand that process of degradation. So that leads us to sustainability. And in this case, we're going to talk just briefly here today about campsite sustainability. What does that mean? Well, the definition would be a sustainable campsite can accommodate the intended type and amount of use over time without unacceptable levels of expansion, degradation, or maintenance. And so again, under a visitor use management, a VUM system, we might have selected campsite size as an indicator, and we're now going to monitor it. And if the conditions become unacceptable, we need to then have some tools to pull out of that toolbox to apply to mitigate that problem and to improve those conditions. One of the things that managers frequently point to as being like sort of the most important indicator is in fact campsite size and or the total aggregate area of camping impact, which would include the numbers of campsites as well as their size. And so we're going to focus on that one today. And managers are experiencing a lot of problems out there these days, and part of it is related to their desire to allow camping to be unregulated or at large, or essentially to let visitors camp where they want to when possible. Unfortunately, our research indicates that when you have sort of at large, unregulated, or unconfined camping, visitors typically create way more campsites than they actually need. And so there's campsite proliferation problems that happen. Another problem is that 2 or 3 campsites in the middle of a really popular area tend to expand in size and grow together. And that's a real problem. So campsite proliferation, campsite expansion are kind of the twin problems that we recreation ecologists identify when we go out and do these big studies in various wilderness areas or in the backcountry of parks and forests and refuges. So we're going to focus on that a bit. And here's just a sort of a listing of some of these problems that we see when we go out and look at places that are, generally pretty highly used and where we've, traditionally allowed unregulated camping. And so this example or case study is from the Pacific Crest Trail. It's called the Twin Lakes Mega Cluster. And just in the last few years, a few of us recreation ecologists have coined a few new phrases. And the mega cluster is one of those. It stands for just a lot of campsites, sort of a site proliferation problem gone wild, along with campsite expansion. So some of those sites become really large. And so the mega cluster is what we're seeing here. They typically form in places that are relatively flat, in locations relatively close to trails and water. And oftentimes there's an attraction feature like a gorgeous alpine lake or a vista or something like that that's bringing people to this spot. And these are the problems that I've been defining here. You can see them in this photo that are resource related. But unfortunately, we also, in these kinds of mega clusters, have social and experiential problems. And so it's not good and it's not acceptable from a social or experiential perspective either. And so here's one that we actually addressed. It was discovered back in 2000 when I got involved with a lot of consulting work with the Appalachian Trail community. And it's the Annapolis Rocks mega cluster. These were featured in an earlier presentation a couple of days ago. But this is a mega cluster in Annapolis Rocks. It's in Maryland. And it was one of the worst, it was probably the worst camping area on the AT back in 2000. And you can see some of these statistics that I've thrown up here and a picture of what that area looked like. I won't really go into that other than to say that the managers and the trail club members had concluded that these problems were unacceptable. And there's another one that Morgan talked about, I think it was 2 days ago, Hawk Mountain down in Georgia, the mega cluster that was down there. I think it's just a few miles, 8 miles maybe north of Springer Mountain, Georgia. So every year we have that through hiker bubble of use that moves northward on the AT. And this is one of the most common places where they camp, kind of the second night out. And as I sort of run through the proliferation of sites that we're sort of modeling here, you can see how site numbers and site expansion occurs over time. And this is what managers are trying to deal with. I think a club member went in here once and found nearly 100 people camped on one night, and that's clearly not wilderness from a social perspective when you have 100 people camping in one general area like that. And so these are the problems managers are dealing with. These are the problems you'll be dealing with. And what do we do about these mega clusters of sites and these mega sites? This is the second term that we've coined recently here. These sites that are larger than around 1,000 square feet are unnecessary, unacceptably large. And we did a 10% sample of the entire Appalachian Trail in a very large study that we've concluded now on the Appalachian Trail, and found that surprisingly 28% of the campsites were larger than this mega site, or were in this class of mega sites. It's interesting that about the same percentage of sites were less than 250 square feet, as you can see at the bottom of this figure. And so that's great. We'd love all of them to be, less than, say, 500 square feet. But what do we do about these really large campsites? Because they are really an unacceptable problem. And so to begin to answer that question, let's look at the use-impact relationship. So in this figure, we have impact on the left. We have amount of use, or nights per year, on the x-axis on the bottom. And what we see in studies, recreation ecology studies, repeatedly is that this relationship is curvilinear. That even as little as 10 to 20 nights of use per year gets you up to that sort of inflection point where the curve changes from going vertical to going horizontal. And in fact, if we take a look at sort of an unconfined or unregulated or at-large camping policy, where visitors are free to create new sites, and they frequently do create large numbers of sites, some of which are unnecessary. We see, in this hypothetical example now that I'm going to run through to sort of demonstrate some things, that, let's just say that we have around 3 sites in an area that is kind of at this inflection point of about 15 nights of use per year. And it could be 100 sites, for example, but we're just going to take 3 as an example, hypothetically. So what could we do here? Think about that. What could we do? We could try to move it to where we had, say, 45 sites only being used one night a year. Okay, so that would accommodate all that use, and disperse it out completely to where we had 45 groups, using a single site one night a year. Doesn't get used the rest of the year. you can probably see already that that would be rather challenging to accomplish from a management perspective. And in fact, it is. It's not really a preferred strategy because of how challenging that would be. You'd need a lot of places where people could camp, a lot of fairly flat spots, right? And if you brought them all into a big flat area, that would be a disaster. They wouldn't probably, do that one night per year. And so there's a problem with that. So containment is generally your much better strategy in any area that has moderate to high use, particularly high use, is a containment or concentration strategy where you would take those 3 sites again, and let's look at those more closely and apply some recreation ecology findings and some management findings. And we're going to pick the most sustainable one of those 3, and we're going to put all the use on that one site. We're then going to close and restore the other 2 sites. And if this curve is correct, and it is, it's been demonstrated in many different studies, not just in the United States, but around the world. If this use impact relationship and curvilinear relationship is correct, as I've depicted it here, it would suggest to you that moving from an unregulated strategy where you have 3 times an A level of impact over there on that left axis to a 1 times a B level of impact, it's higher, it's more impacted, but not much more. From an aggregate perspective, a containment strategy gets rid of 2 of those sites and all the impact associated with those sites. And we'll see that in just a few minutes with the Annapolis Rocks case study. And so from a carrying capacity perspective, you often have all this emphasis on the amount of use and that we're loving our campsites and our wilderness and our parks to death. In fact, what we're finding is that the amount of use is not necessarily the most important factor to be manipulating. And so trying to set a trailhead quota or restricting and rationing permits is not necessarily the best answer. The best answer is shifting sites, shifting people into a containment strategy where you're trying to focus all that use on a smaller subset of very sustainable sites. That in fact is way more effective, according to our recreation ecology research, than is limiting or rationing use. And that's a little bit counterintuitive. So we'll talk a little bit more about that. But it begins with, and here's sort of the toolbox that I'm going to kind of wander through fairly quickly here. It begins with deciding what sort of a strategy are you going to apply here, a dispersal strategy or a containment strategy. So let's go back to this chart and look at those 2 options as being, again, the place to start, the most favorable, the most effective, the most optimal management response to overuse. So I mentioned dispersal is an attractive strategy because it could eliminate all impact, all visible impact, all campsites. In fact, as I said, it's not easy to do, but let's still take a look at it first. A pure form of dispersal is getting people to use one site once a year. And if you could do that, it would be an effective practice. But we need to know what types of sites. So we're going to focus on that for just a minute. So here's sort of you've probably all heard of the leave no trace, travel and camp on durable surfaces principle, where we talk about either dispersing use, like doing meadow walking and such, not walking single file, but walking abreast of each other. The camping sort of corollary to that is you either camp in a really resistant place, like on these grasses here, or in a really resistant place in the forest, which would be a place that has no ground cover on the ground. In other words, it's so dense and shady that you really don't have very many plants. You're just kind of camping on organic litter. Or you contain use and you concentrate it to the smallest number of sustainable sites possible. And we'll come back to that one. But on the AT at least, we're finding that it's up to around 11%. It might even be a little higher than that now, of the through hiking and long distance hiking community are now using hammocks, which is great because you're camping above the vegetation now. And as long as you're using wide straps on the trees to protect the bark, it's a pretty low impact, no impact form of camping. Other options, though, more normally would be tent camping, and you either put your tent, on non-vegetated organic litter, like in the upper right picture, or you put your tent on really durable, resistant grasses in the lower left. But then, irregardless, it's best if you can then concentrate your cooking and your, sort of social activities on a really durable surface like bedrock. And that's what's being shown in the lower left picture. Is there's a naturally occurring bedrock area where this is my venture crew group of youth are hanging out to cook dinner and talk and play hacky sack and things like that. So I've mentioned a couple of times now the durability of grasses. I want to show you sort of a comparison from an experimental trampling study, and just visually here real quick. These forbs, these broadleafed herbs that grow in most forests, they tend to not be very resistant to trampling impact and not very resilient, which means they don't bounce back, they don't recover very fast. And these pictures kind of illustrate that. But if we do the same exact study only 100 yards away in a meadow, we see these results. And these results show us why we plant grass on our football fields and our soccer fields and our front lawns. Grasses are inherently highly resistant to trampling traffic. And if they are trampled down, like during a football game, they tend to be very resilient if they're in full sun and if they have enough nutrients and soil moisture. But in most conditions, these meadows are in fact very resistant, very resilient. And so putting tents on grasses is not a bad thing. Particularly if you can find a cooking spot that's like durable bedrock. And so that's what I often look for. Obviously, if you have a freestanding tent, you can set up on bedrock entirely. So enough of that. Let's move on back to the containment or concentration strategy here. We've just talked about dispersal. Now we're going to talk about containment, which again, as I said, is really your best bet if you've got moderate to high use. And so there's sort of two options here. The first is my preference, which is established site camping, where you're essentially just asking and pleading with visitors, hey folks, please stay on the most sustainable subset of sites that are out there. And we're going to talk about sustainability in a few minutes, what makes a sustainable site. But let's use a subset of the most sustainable sites, and let's avoid all these non-sustainable sites. Again, I'll define that in a second. And so there's advantages in visitor freedom. Visitors can pretty much still choose and select a campsite of their choice. The disadvantages are that you've got to have a fair number of these sites out there in various places for people to find and use them. And we'll talk about finding them in just a few minutes as well. The other option in really high use areas like that, super attractive alpine lake basin, for example, or the amazing vista, or maybe there's a waterfall site that everyone wants to camp near. In those kinds of places that you have essentially unlimited demand, you kind of have to bite the bullet, even in wilderness, and use designated site camping. And in most cases, that's your best management bet in the truly high use areas, is to break down and just simply accept that you have to do designated site camping. And now it's a regulatory thing. Like you would literally have to go out and enforce that with either volunteer trail stewards or LEs, law enforcement officers that write tickets, or maybe warnings and then tickets. But with this method, you can absolutely put people on the most sustainable sites again that you can use and reuse many times with limited impact. And there really is truly a difference between unsustainable sites and sustainable sites. You'll have to trust me on that for a minute or two. Shenandoah National Park has a policy where they combine all of these options. And so they have designated site camping in high use areas, like at their shelter sites, which have water nearby. They actually promote established site camping in their lower intermediate use areas. Hey folks, just use any pre-existing campsite. Don't make any new sites. But in these intermediate use areas, use established sites, and then they go out and try to get rid of the non-sustainable sites. They close them and restore them. And then they do allow, but they don't market, dispersed pristine site camping. And so you could basically go and find a place just in the woods, kind of hopefully, out of sight of the AT, for example, barely, and hang up your hammock or put up your tent on an area of just organic litter, for example. Now, you can't do that close to shelters where they have designated site camping, but you could do it anywhere else. And I do it all the time. And then those places that are unsustainable or that you just have too many campsites, you don't need them all, then you close and restore those, which again is no easy task, but we'll talk about that very briefly as an example. And so we're now at, we've got these two strategies, just, pristine site camping, a dispersal strategy, and then containment, which is either established site camping, where you're promoting the reuse of a subset of sustainable sites, or designated site camping, where you're requiring the use of a sustainable, smaller subset of sites. We now want to select or construct these sustainable sites. So now we're going to talk about, well, what is a sustainable site? This camping confinement or containment strategy can be very successful. There's many places where it has been implemented quite well. And here's a couple of examples of sites that look great, and they do concentrate and prohibit or at least discourage the site proliferation and expansion problems that are kind of the age-old dilemmas here. Both of these sites are in slightly sloping terrain, and the terrain itself, brings people to the right spot. So we've done lots of studies of this in various places. The most recent study, as I mentioned, was on the Appalachian Trail. It was a 4-year study, and we did a lot of regression modeling, and there's some journal papers that I'll refer you to and give you a link to see if you're interested at the end of the show. But what come out of those analyses and also just long discussions with managers about what's a sustainable site is these 4 factors, sloping topography being the most important. If you can move camping out of the big flat areas where site proliferation and expansion will be basically easy, and will always happen, and you'll be fighting it forever. If you can move the camping away from those places into sloping terrain where there's only a limited number of places to camp, and where topography will be sort of fighting on your behalf to prevent, proliferation and site expansion, then it's a win-win. It's a sustainable forever solution if you can do that. And in fact, we are doing that in a lot of places now. It's the latest, sort of best practice and from our toolbox. And a second thing is, along with that, is we can in fact even go out and construct side hill campsites. We go into sloping terrain, like 15% grade or steeper, and we dig just as we would a side hill trail, which we do all the time in wilderness, right? Side hill trails, we'll see those in a few minutes. And we dig a side hill campsite, and we put people on it, and the topography prevents it from expanding. And other issues, other factors or attributes is rugosity. Getting a phone call here, which I hope isn't saying that my presentation isn't running. I think it is. Regression has shown us that rugosity can be a factor. Really rocky areas, and this is particularly true out west, where the rockiness does in fact prevent site expansion and proliferation. And so we call that rugosity. And then finally, grasses. If you can get people to move their camping into grassy areas, and this is only true if you have lots of grassy areas that are available. If you got a rare meadow, it's not a good idea probably to do that. But again, grasses can in fact be exceptionally good places to camp if you have enough of them, enough places. And so we've also been doing research in the Pacific Crest Trail. And in the Pacific Crest Trail, we've found that there are sometimes some of these naturally occurring places that are sort of side hill campsites. And we've even used GIS analyses to go into those areas, particularly when you have LiDAR data for topography, which is really accurate topography data. And we can find these small flat places in the midst of a sort of a sea of sloping terrain. Again, best if it's more than 15% grade. And these are shown in green in that lower right-hand slope map. Those are the flat spots in sloping terrain, which is red. And we can, the next question is, okay, so let's say we can apply all of those attributes that I just mentioned, the topography, the side hill sites, either naturally occurring or constructed, the grasses, the rugosity. And let's say that we apply all those factors and we find a subset of sustainable sites. How the heck do we get visitors to go find those places? And quite frankly, and this is a bit controversial or a bit new at least, is cell phone apps. Many hikers and backpackers are now using cell phones to navigate. And it's a trend that's been happening almost all through hikers on the long distance trails are using these things now. And an increasing number of sort of weekend backpackers and section hikers are using them. Some managers are a little concerned about that in wilderness in terms of wilderness character, but quite frankly, the visitors are in the control seat here. They're in the driver's chair, and they are increasingly using them. And these cell phone apps, if you put sustainable campsites into them, it's a perfect tool for getting visitors to be able to find these sustainable sites and use them. You're sort of marketing the sustainable sites by including them in the apps and taking out the non-sustainable sites. You could even put site closure markings on the non-sustainable sites in the phone apps, which would communicate directly to visitors. These are not sites that we want you to use. They're closed for restoration. So it's kind of a new world. I won't belabor that too much. I need to move on and talk about, the side hill sites and then get on to trails here in a few minutes. But side hill campsites look like this. They're obviously, again, constructed in sloping terrain. And in fact, this has been something we've been doing on the AT, in the AT community for literally 20 years. And according to our research, we turned up an estimated 725 side hill campsites have now been created by the AT volunteer club members up and down the entire AT. You find them everywhere along the Appalachian Trail. And they've been constructed. In some cases, we've just found a small flat area in sloping terrain and turned it into a campsite. In other cases, we've used the traditional cut and fill practices, shoring it up with rocks and logs, to create these sites. So we did that at Annapolis Rocks back in 2002, roughly. We closed all the big flat areas where we had this mega cluster of mega campsites. And that's in the green on the left side of this figure. And we moved all of that camping over to these new side hill campsites that were created in sloping terrain. Now, we did make a bit of a mistake in that the sloping terrain that was available was more in the 12 to 13 and 14% grade. And as it turned out, a few of those sites have expanded. We've now decided that you really need to move these sites into 15 to 20% slopes for this practice to be really effective. It was predominantly effective here at Annapolis Rocks, but unfortunately there wasn't any terrain that we could have moved them to that was steeper. As you can see here, we had a 92% reduction in the total area of camping disturbance. So we had a reduction in the number of sites and in the total area camping disturbance. And here's a picture of kind of before and after. This was taken about a year or two after a site was closed. And this picture was taken in 2019, just a year or so ago. And you can see some pretty substantial recovery. As I said before, grasses are very resistant and resilient. And this is a measure of the resilience, the recoverability of those grasses. A few more things I'm going to run through pretty quickly and then get to trails. You can provide facilities. And so there are some facilities that can help managers reduce impacts. What they do is they identify the singular place where, for example, you want them to have a campfire or cook their dinner. And so you provide maybe an iceberg set of campfire rocks here where they're dug into the ground and visitors can't easily move them around. You don't want campsite fires moving from place to place. That makes for a bigger campsite. We want to nail that down and anchor it to one spot. And so you could iceberg these rocks. And that's what we're showing here. You could also put in a very large flat rock and set it up on some chunky rocks to make, essentially a kitchen table where people come and say, gee, where should I cook dinner? Oh, look, there's a kitchen rock. Let me use that. Again, you're spatially concentrating the camping activity to a defined spot and you're anchoring it there. You can take this further. In wilderness, it's a bit debatable, but when we did a study in Banff National Park in Canada last year, we saw traditional campsites like the upper left one, but we also saw these tent pad campsites, and there's quite a number of them in that wilderness. And they were very effective, even in flat terrain, which was surprising to me. You can see a little bit of spillover there into the flat terrain, but for the most part, 99 out of 100 people put up their tents and concentrate all their activity on those tent pads. And in addition, they had some facilities. Now, this is a little more debatable as to whether this is appropriate in wilderness, but in their case, they have grizzly bears, and grizzly bears occasionally attack and eat people. And so you want to really separate the cooking, eating, and food from your tenting locations. And they have very strict policies up there to protect the wildlife and the visitors, where they separate these. And by having the tent pads that are anchored and having the cooking area, which you see in the lower right, which is anchored, and having those two things be far apart from each other, that's sort of why they did it. That's, it's separating cooking food and camping with your tent. And they, again, the food storage areas, again, because they have grizzly bears, they're willing to have these facilities. And again, the facilities are anchored and they're away from the cooking, or they're away from the tenting areas. And so they've done that in addition to other actions, but they've done it in wilderness and justified it on those bases of protecting the visitors and the wildlife. And I quite frankly agree with them. So even in wilderness, those things can be done. They're not necessarily optimal, but they are tools in the toolbox and they're open for debate. You can also maintain and rehab campsites. And I like to call this sort of a push-pull practice. And so you can push people away from the places where you don't want them to camp by doing things like iceberging rocks and throwing in some leaves and brush and making it look natural again, sort of natural restoration work. You can also pull people to the campsites that you want them in by, again, marketing it, for example, on maps and in guidebooks and in phone apps to market a subset of really sustainable sites, or going to designated site camping if you have to. And that pulls people to the sites you want them to use that are in a sustainable location. And then you could, have some, some facilities there, like the iceberg fire site and a couple of logs to sit on and things like that. But again, on the primitive side, maybe a kitchen rock. And you do want to kind of go into the sites that you want them to use and make sure they all have perfect, tenting spots. And so taking out a root or two or a rock and filling in a hole or a depression and trying to pick really good tent spots and subtly improving them, that's all fair game. That's all good work, good maintenance work. I mean, we maintain trails all the time. Why wouldn't we maintain campsites too? We're trying to get people to use these sustainable sites. Then we ought to make them really attractive to people. We ought to satisfy all of their desires, that are reasonable in wilderness, like a smooth, well-drained tent pad. That's not that hard to create and maintain. And then the last issue here, and not least, is to educate or regulate visitors for campsites. So we have the 7 principles of leave no trace. They have various components. I don't have time to go into them. As passionate as I am about leave no trace, I actually wrote their official book a few years back. There are many different practices that apply here. Again, just don't have time to talk about them. And then there's regulations. And so if the education doesn't work, you can do other things. If you've got lots of trees being felled, you could prohibit axes and saws, these woods tools that people use. The leave no trace practice is to pick up dead and down wood you can break by hand, no bigger than your wrist. You really don't need the axes and saws in almost all instances. So you can designate campsites. We've talked about that. Those are rules and regulations that then have to be enforced either with trail stewards or through a law enforcement person writing tickets. So that kind of concludes the campsite work. We're going to talk about trails. It's not quite as long. The common trail impacts that we're concerned with that you might pick indicators for would be trail widening, excessive soil loss as shown in the lower right picture, and then muddiness as shown in the lower left picture. Those are the three kind of problems or impacts associated most commonly with trails. All right, so what has recreation ecology research told us or informed us of from sustainable trail studies? Soil loss, I would highlight as being kind of the most important indicator. It's, when you lose soil, it's not coming back in a human's lifetime, short of bringing it back in a wheelbarrow. And so we really want to prevent that. Vegetation impacts are bad, but they're more temporal, they're more dynamic. If you fix a problem, the vegetation will come back in some reasonable time within your lifetime, but soils, not so much. And so we're going to look at a different set of tools here from our toolbox. Alignment, according to some of our research, is quite frankly the most important factor. Again, way more important than amount of use. Way more important than amount of use. Think of any trail that you know well. I'll bet you that the majority of that trail has, basically just, great trail conditions. It's not too wide, it's not muddy, it's not eroded. But on that trail, I'll bet you there's some parts that aren't so good, that are muddy, that are eroded, that are really wide. And yet that whole trail that you're thinking of, a mile or two long, gets the same amount of use, the same type of use, the same season of use, the same maintenance level of effort. All of those things are pretty much homogeneous, and yet that trail has some bad parts. So do you really want to reduce use of the entire trail, or do you want to go fix those problem spots? We really want to fix those problem spots. And so we can construct or reconstruct. If we need to, we can relocate, parts of that trail to put it in good alignments, in good locations. In some cases, you do have to relocate something. Generally, we sort of throw maintenance at these trails. And when we find ourselves returning again and again and again to the same spot to do maintenance, we start thinking, you know what, we should probably relocate this section. And it then makes sense, I think, for the forever sustainable solution to engage in a relocation. And so what are the attributes of a sustainable trail? And again, we're going to talk about soil loss because I think that's the most important indicator. It's the most long-term indicator that, when I see massive soil loss, the word impairment jumps into my mind. And the Park Service, for example, is forbidden from allowing any impairment. And so that's going to be our focus. And so what we've done is done a lot of relational analyses using trail data sets that we've collected in various parks over the years. And what those data sets and those analyses show us, again, it's multivariate modeling, often using multiple regression, are these three factors. And I'm going to add a fourth as well that doesn't seem to always come into our equations, but we know it's important. The first is trail grade. This is kind of a duh. If you have a really steep trail grade, it's going to erode, it's going to carry soil. We all know that, so I'm not going to belabor it. One that we're not quite as familiar with is trail slope alignment angle. And this refers to, is the trail going straight up the fall line, or is it more sort of like parallel to the contour line? And those two are 90 degrees apart. Think about that. I'll show you a figure here in a minute. And then finally is trail drainage. Obviously, if you've got a trail that has no drainage features on it, and if it's carrying water, if it's intercepting and carrying water, there's going to be erosion, soil loss, and so drainage features get that water off the trail periodically. The fourth factor that I alluded to is trail substrate, and mostly it boils down to not so much about texture of the soil as much as it boils down to how much rock, either gravel or large aggregate rock, is there in the soil matrix. And soils that don't have any rock in them are problematic. They're more dynamic. They move, they get displaced, they get eroded. Those are the problems that we're fighting. We don't want our trail substrates to be something that can be displaced easily or eroded easily. And rock in the soil is what prevents that. So let's now go and look a little more in depth into particularly this trail slope alignment angle issue. And I call this TSA slope ratio. Some of you have heard about the half rule from IMBA, the International Mountain Biking Association. Same thing. It's getting at the same idea. Is this trail going up the fall line like in the left picture, or is it on the contour like the right picture, which is a photo from Great Smokies? And what we found in our research, and here's a figure from one of our published peer-reviewed journal papers on this, is that if you're within about 22 degrees of the fall line, this is if you dumped a bucket of water on the land, it would run straight down the fall line. If you're within 22 degrees of that, it's bad news. You're going to have a really hard time draining that trail. Once it becomes incised, the water gets attracted to that incised tread, and you're defying the laws of physics to get it out, short of having a pump, because water doesn't go uphill. It's going to go straight down the hill, straight down your trail, and it's going to erode if the trail is steep. Again, trail grade being the other really important factor. If you're down near the contour line at 9 degrees opposite the fall line, then one side of the trail is always way lower than the other. And that means you can either outslope the trail tread by, say, 3%, or you can put in a water bar, armored with wood or rock, or a drainage dip, it's not armored, just simply digging a trench and mounding the soil downhill. And so you're probably familiar with those kinds of tread drainage features and actions. This is, one sort of important figure that shows the combination of both of those things. The trail slope alignment, the top line on this figure is our fall-aligned treads. The lower axis on x-axis is trail grade, with the grade being steepest on the points on the right side of this figure. And so you can sort of visually see the influence on soil loss, which is the axis on the left. That's CSA is cross-sectional area soil loss. Okay, so that's soil loss over there. And the fall line trails, you can really see the influence here, the top line, but you can also see the influence of trail grade. Everything on the right side is more eroded than everything on the left side. And you can put these two together, and we've done that. And we've published a paper where we created a trail sustainability rating system based on these two attributes that have been found to be very influential. Again, way more influential than amount of use or limiting the amount of use. These are the most influential factors, is trail slope and this trail slope alignment angle. And you put those two together, and here's some data from, again, our study of the Appalachian Trail, a 10% sample. You can sort of see, hopefully you can see this row right here of 3 to 10% grade, but not fall line, not that category, but that's your best place to be. That's the most sustainable 3 cells in the entire matrix here. You might ask, well, why isn't this row here of 0 to 2% trail grade, why isn't that road really sustainable? That row isn't sustainable because muddiness can happen. If you've got a trail in flat terrain and it becomes incised from soil compaction, displacement of soil, and things like that, a little bit of erosion that can occur, again, that water will collect in your trail tread and just sit there. You can't drain it because the trail is too dang flat and the terrain around it is too dang flat. And so you really ought to avoid the flat areas. They won't erode, but you're better off being in a 3 to 10% sort of range. And the rest of this is pretty self-explanatory. Like the bottom row here, that's greater than 20% trail grade. That's really bad. That's very steep and it's going to erode. And then at 11 to 20% trail grade, 9.5% of the AT, as we measured, was in that location, but that's fall aligned. It's not quite as steep, but it's fall aligned, so that makes it bad. At any rate, you can use this to sort of come up with good, neutral, poor, and very poor, and you can then apply it to a park or a wilderness area, for example, or a Forest Service backcountry, and come up with these kinds of settings. All right, you can then use GIS to convey those to managers or volunteers using color-coded segments of your trail, and you can then use that to target trail maintenance work or relocation work or maintenance work, and then go out and try to fix those places or relocate them. I want to really focus a little bit now on sort of the construction of sustainable trails. And so when you're either relocating or constructing a new trail, you really want to emphasize side hill designs. That's again related to that fall line alignment. And so side hill trails with outslope treads are really the most sustainable. Putting in rolling grade dips or tread reversals, I'll show you a picture of that here in just a second. You can armor the trail. If it doesn't have rock in the substrate, you can add it. Obviously, graveling trails can be done. Even in wilderness, you can create natural gravel by pounding up rocks and making angular pieces, or in some cases, you can import that if you've got pack stock and whatnot, mules to bring that gravel in, not very much, but at least some. Or using natural native rock to armor the tread and make rock steps and stone staircases and things like that. But essentially, you're armoring the tread. And here's just a couple of pictures of regular old side hill trails that sort of prove visually that these side hill trails are just the most sustainable alignment possible. These trails, water would come down the slope, hit this trail. Your goal is that trail is hydrologically invisible, that the water hits the trail, goes across the trail because the tread is outsloped. There is no berm, ideally, no berm on that lower side that would prevent the water from just continuing to go straight down the slope. And so these trails ideally don't capture and transport any water. They're hydrologically invisible. That's our goal. Now, if there is a big berm, then you have to go to tread maintenance, tread drainage features. And you can do that. The best is to not have water bars and things like that, but to have grade reversals where you take the entire trail tread, and you bring it downhill and then back uphill again, just briefly, like over 15 or 20 feet. And if you have these grade reversals, drainage dips, rolling grade dips, there's all different names, but essentially it's a reversal of the trail tread just briefly. The trail's generally going uphill, but it takes a short dip downhill and then resumes going uphill again. All water has to come off of that trail, coming down that trail and down the slope, because the trail tread itself goes uphill briefly. And so, that kind of a feature doesn't ever need to be maintained generally. And so it's sort of the forever sustainable solution, more effective than water bars and things. And then you can armor treads like this. These rocks have been placed, and the beauty of it is that they look like they're naturally occurring, but some very talented trail crew installed these rocks in a fairly natural looking trail staircase, and that's why I'm featuring these, because I prefer this over the standard trail staircase that you would see, particularly in wilderness. Again, I mentioned maintenance briefly, is that you can install and then you have to maintain forever, every year, forever, an adequate density of tread drainage features if you don't use an outslope trail and grade reversals. You can, as I mentioned, apply rock or gravel, either to the substrate of the tread or in the form of steps and armoring. Particularly if it's a horse trail, you have to armor it sometimes. And you have to pretty much match the intensity of that trail maintenance effort to the intensity of impact. And again, if you find yourself going back to the same place again and again, year after year after year, you ought to start wondering if maybe that place needs to be relocated. That's the forever solution, is to relocate the trail to avoid those problems. And here's, just a couple pictures of water bars. Both of these are rock reinforced water bars. And I included these because both are examples of what not to do. The angle here is such that, imagine water running down this trail, which is somewhat incised, even though it's side hill on the left one. And it hits the water bar and it sort of stops the water because it's almost straight across the trail, not at an angle, but straight across. And when water moves and then stops, it's going to drop some of its larger sediment load, like small rocks and sand and bigger particles. Clay particles, really tiny ones, are going to stay in suspension. They'll go off trail and then drop out when they get filtered by veg or leaf litter and things like that. But the angle of those things needs to be maybe at 45% or 45 degrees rather than more like a step almost. And then you can do other things too. I don't have much time to talk about this in detail, but you can see in the upper left that you've got multiple trailing through a meadow. In the right, the managers and volunteers have chunked it up with some logs and rocks and done some plantings and things like that to identify for the visitors, this is the actual tread we want you to use. Don't use these other ones. And then finally, what it's all about is sort of you really want to prevent this non-desirable future condition here where you've got, two visitors coming to enjoy their wilderness and they get to the trailhead and there's this kind of a sort of a funny sign which says that, well, we've had a lot of use here, we've had a lot of impacts here, and part of our wilderness is sort of irretrievably lost, and part of it is completely spoiled, and so on and so forth. And oh, by the way, the unspoiled part, the pristine spot, is way the heck in the most remote place. And if you really want to see that, you're gonna have to walk a long way. And we don't want that. That's an undesirable future condition. We really want to professionally manage the visitor use, and we want to combine, as I said at the beginning, the best that science has to offer and the best that that the managers and the volunteer stewards have to offer. And I think when we pull all those things together, and when we talk to visitors as well, we come up with really the most optimal tools that we're pulling out of our toolbox. And so we're not jumping and grabbing onto the rules and regulations and law enforcement options. We're talking about, well, gee, let's move our campsites and our trails to the most sustainable locations. If we have to do some work to construct sustainable trails and to construct sustainable campsites, then we should do that. And if we have to do some work to professionally maintain that infrastructure of sustainable trails and campsites, then we should do that. And that's the place to start, is we start with site management actions, with sustainable management. And then we move into maintenance, and we move into education with leave no trace practices. And then if we really have to, if none of those things work, and we have a visitor use management framework with indicators and standards or thresholds and monitoring to see if it's working and to see when it's not working, we use that adaptive management process of decision-making that's permanent, ongoing, not a plan that you put on the shelf and never look at it again. It's a living, breathing, dynamic decision-making process that's adaptive. We use that to then justify when and where we have to limit use and ration use. That's sort of the last tool that we pull out of our toolbox. Again, this is my personal opinion based on 4 decades of working in parks and wilderness areas. You need to make your own decisions about that. But from my perspective, I think we should be embracing recreational visitation in our protected natural areas, but it's our job as stewards to avoid avoidable impact and limit that impact which is unavoidable. And to do that in such a way that we are not unnecessarily restricting visitor use to these amazing protected natural areas that are part of the sort of public lands that we all collectively own and that we all cherish and love. We just want to make sure we don't love them to death, right? So that's the end of my talk. We're going to have time for questions now. I do have a number of publications, and in particular, this one at the very bottom. It's really, I think, the best collection of best management camping practices that I've ever been able to produce, and that perhaps exists in the world today. Go take a look at it. It was designed for the Appalachian Trail. I'm currently working up on a new version of that for the Pacific Crest Trail, which will be a little more Western oriented. That'll be out within 6 months or so. But the best management practice report for the AT is done. It's on this web at this folder location, and I think they're going to be able to highlight that for you to go and access it. There's also a number of journal papers there as well. And so by all means, contact me if I can ever be of assistance. I do a lot of technical consulting work with the management agencies and the clubs. I am happy to do more of that. And so drop me an email. I can always send you publications and things that will answer a lot of your questions, and then consult as a follow-up. So with that, I'm going to conclude this part of my talk and see what sorts of comments and questions we may have. So let's see.
Hey, thank you, Jeff. I can field these if you want and send them your way. And I was just going to remind folks that if you want to raise your hand and ask a question, we can do that as well. 4 decades of experience from Jeff, Marion here. It's great to be able to take advantage of this. And so, so that folks, when we have the recording, know what the questions are, it's nice to be able to read them out. And so from Eric Dodd, one of the challenges of my location is the topography: steep gorges, flat ridge tops, and sheer cliffs. Visitors are drawn to camp on flat ridge tops due to vistas. Campsites could be designated on side slope. However, that would put them close to the cliff tops and 100+ foot drops. Any recommendations? Do we have some rockiness that we could utilize? Mostly hardwood, leaf litter, and limited grass.
Yeah, that's an excellent question. In fact, I've both done some studies in the Daniel Boone, and I've also taught a master educator leave no trace course there, so I'm quite familiar with it. And essentially, there's sort of a cliff line, and then above the cliffs is sort of these flat plateaus that you often see, like in mesas out west. And a lot of the camping does, in fact, occur on those sort of flat plateau areas. And so it's a very challenging area. You're not going to find a lot of side hill terrain unless you can drop people down below the cliffs. Fortunately, you can. Most of the trails do transcend the cliff line. And the problem there is that many of the slopes and the below the cliff areas tend to also be rather steep. And so you don't get terrain that's in that magical 15 to 20% grade. My suggestion would be, you can do 2 things. The first is you can get GIS up and running there, and you can look for and do slope maps and identify all of the terrain in the forest there that's in the 15 to 20% area, and then go look in those areas for flat spots and move the camping to those places whenever you possibly can. The other option, quite frankly, is to think more about those practices I shared from Banff National Park, where they have some of those tent pads. Those work in flat terrain. Doesn't necessarily have to be log cribbing. It can just we see a lot of those kinds of campsites where they just embed a few rocks on 1 or 2 problem sides of the campsite to say, this is the border of the site, don't go beyond this. Or maybe if you have to, bring rocks all the way around the tent pads. But it is a challenging place. Fortunately, that's not the norm. That most other protected natural areas do have lots of other options. And so it's just a little more difficult to work in that particular location based on my experience. So good question. Others?
Great. I got another one from you, Ashley H. She says, any suggestions on colleges in Arizona for an MS in recreation ecology?
Yeah, so there's really, unfortunately, just a few of us. Maybe we're talking about less than 10 recreation ecologists in the entire United States. These would be people that would like introduce themselves as a recreation ecologist. There are none in Arizona really at this point. Pam Foti used to be there, and she's, I believe, now retired. But you can often still go to a good park and rec program with all the social scientists who tend to be the professors in those programs, and then work remotely with a recreation ecologist. I've done that many times over the years with people who ended up at a different university, and I'm willing to consult and give you ideas and even be on committees occasionally. I'm not sure to what extent my colleagues, like Yufei Lung, who's at NC State University, whether he does that as well, or Chris Mons out at Utah State University. So there are some university folks out there if you're willing to go to where they're located. And I can share with you some of the schools where it might be best to pursue graduate work. But you can use a social scientist as an advisor and still do some recreation ecology work. You just it's on you to really get into the rec ecology literature and learn that well and apply it well, and then to consult a bit on the side with a trained, experienced recreation ecologist. Good. Other?
Great. I see Cam O'Connor, you have your hand up if you want to ask your question.
Yes, thanks. My name is Rory O'Connor. It's my wife, Kim. And yeah, I guess my question is, we're working in an area where we're, it's kind of got like a 3-mile backcountry lake access at 3 miles. And then at maybe 4 miles, you got another pilot lake into that lake. And then if we're getting 6 miles back, we've got some other lakes and just spectacular spots. And I guess my question is coming about, okay, so obviously we're getting a tons of use at the 3 and 4, but we're in my career, I've never really been concerned about those 2 spots because I'm more concerned about the backcountry. And so I'm just kind of turning an eye and anyway, but now I'm getting tasked with, okay, how we got to start addressing these 6 milers, these 8 milers, these 10 milers. And I'm really trying to maintain some, the problem with my area is just, it's spectacular, unfortunately. And it's just one of those things that, we're working on concentrating and how we're concentrating on these 3 and 4. And I'm looking for some advice how to start addressing, because I'm seeing my 6 miles, just like, pristine meadows that I never would ever maintain a fire ring in. And, I'm tearing that fire ring out every year. So yeah, if you could briefly on that, if you understand my question is that these guys, these folks are getting more interested and we're getting more of these folks back there.
Yeah. No, it's an excellent question. And it's a common dilemma. You're always going to have these, really attractive destination places to camp. And, the first ones that you encounter when you move out of a trailhead are the ones that are going to get hammered. And so I think it gets back to what I was saying earlier, which is, pristine site camping is not going to be your option in those places, probably. I mean, they're moderate to high use. And so containment is the first notion, is to embrace the containment strategy. The second is to go into those places and decide which of these sites are sustainable. Which of these sites could we double, triple, quadruple use on, and they'd stay the same size. That probably means that you want to avoid the flat terrain and get the camping out of the flat terrain. And if you have to move your trail to hide the flat terrain, then move the trail, even if it's a formal trail that's been there for 40 years. We've learned that lesson, and when we've done that, it has been remarkably successful. And so bring people as they want to look for campsites through sloping terrain that's 15 to 20% grade, and show them campsites in those places and get them into those campsites and avoid the camping in the flat terrain. Whether it's 2 or 3 miles in or 6 miles in, I would argue makes no difference. Now, if that doesn't work and you can't do that, then go to designated site camping. I think you can then justify designated site camping in the areas where you have unacceptable conditions. Unacceptable generally means site proliferation like crazy and site expansion, that's just gone wild. And to then, start to rein that in by doing designated site camping. It is the case that we made mistakes in the past, where we said, oh, gee, this particular lake basin that's close to the trailhead has just gotten hammered. So we're going to close all camping here, and that will force it to go somewhere else. And we've learned that lesson too many times, management-wise, through management experience. It generally doesn't work. It's like, you squeeze the tube of toothpaste and the toothpaste goes somewhere else in the tube and creates problems there. And you really want to avoid that problem. And so professionally managing the camping, regardless of whether it's at a close or a more remote, somewhat popular place, is the answer. And the answer is to move campsites into sustainable, move people to sustainable sites, regardless of where they are. And I think I've covered all that pretty fully in this talk. It's mostly about topography. The realtors, when they say it's all about location, 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 the realtors would make good wilderness managers because they recognize that. You need to move the camping out of the bad locations and into the best locations. And then if none of those things work, then you can start talking about trailhead quotas and moving folks around and forcing them to go to other places. But by and large, the site management is the ticket. Everything that I've learned in recreation ecology says that you can solve 90% of these problems with site management solutions. As much as I love Leave No Trace, I'm going to tell you that site management is far more popular than rules, regulations, and Leave No Trace, with the exception of requiring designated site camping in the places where you have really unlimited demand for camping. So hopefully that helps. I'm happy to talk with you personally if you want to send me an email.
Thanks. So we had about 5 more minutes and a handful of questions still, so we'll get to what we can. G. Snyder says, fantastic presentation. Can you point to research and tools related to very high day use impacts and mitigation strategies specific to day use?
Yeah, so I did a study ages ago with a couple of colleagues, Joe Rogenbuck and Bob Manning, on day use, and we've got a publication on that which I could share. But quite frankly, the day use is kind of the new frontier these days. We're getting more and more people who are coming into wilderness areas on day use hikes. And they're going to the most popular scenic places, and in some cases, distance is not really a barrier. I'm seeing day users that are willing to hike 15 miles in a day, and we didn't have that historically. And particularly in backcountry areas with bicycles, we're seeing that happen as well. But I think. Sort of Leave No Trace education is probably the more appropriate action for heavy day use. In other words, what are they doing that's problematic? They may be taking breaks in fragile rather than in resistant locations. Could we have them step entirely off the trail and find a piece of bedrock to hang out and take rest breaks on, or eat their snack or their lunch on, and that sort of thing? If they're going to go up to an alpine lake and go swimming, could we try to get them to find a really durable, resistant rock shoreline and go swimming there instead of going swimming from the riparian zone that has soil and riparian vegetation all over? Can we get them to move over to the rocky areas? And so there's things like that. And I think that's the more appropriate domain of Leave No Trace. And you may have to, modify some of those practices. In other words, what does use durable surfaces mean? Well, in the case of swimming and hanging out, it means, don't use the soil veg area, use the rocky area. And generally there, that is possible. If you have to, move the dang trail so that it goes straight to the rocky area and avoids taking them past the soil and veg areas. Again, thinking for the forever sustainable solutions, which involves moving campsites and moving trails out of susceptible, fragile places into really resistant, durable places. That's the forever solution. If you don't take that solution because you feel like, oh, that's, we can't do that for whatever reason, you can think of a million reasons why not to do that. All I'm saying is that if you don't do that, you'll be fighting this, and the people who come after you will be fighting this forever. And so I always recommend lots of brainstorming to identify the most sustainable forever solutions and moving as hard as you can towards those solutions in lieu of, oh, let's try education, or let's try, rules and regs and law enforcement, or limiting use, those are less attractive solutions to me as a recreation ecologist.
Great, thanks. This is probably the last question here. I'll let folks know I'm gonna drop the eval in the chat so you can respond to that as well. There's an entire thread on here about different GIS platforms or apps to use in collecting data. Do you have any thoughts on that?
Yeah, absolutely. GIS, particularly now that we have LiDAR data, and you'll have to look into that if you're not familiar with it, is becoming a very powerful tool in recreation ecology and in the professional management of camping and hiking. And so that's the most important thing I will say. And so look into, if you're a young person wanting to get into this work, I strongly recommend that you take an ArcGIS class and master that software package. It's absolutely a key to the future, and it's going to be an invaluable tool. Secondly, the cell phone. The cell phone is becoming an equally invaluable tool. Some people are concerned about this. I'm not one of them, and I'm an older person. We are now using cell phones to navigate in wilderness. People need to know how to use a map and compass. Your cell phone could break or run out of batteries, but it has incredible advantages, both for the visitor to navigate and to find these sustainable campsites I've been talking about, as well as for managers to figure out which campsites are sustainable. We use a phone app now for data collection. The one we use is called Fulcrum, Fulcrum. There are many others, but we use Fulcrum, and we collect all of our campsite data, all of our trail data on the phone app. It has quality assurance, quality control features in it. It takes pictures. It links those pictures forever to your data and to locations. Every bit of data we collect is geo-referenced. These phones now are talking to 4 different constellations of satellites. The data accuracy has increased dramatically in the last 5 years for cell phones. They do not need to be in cell tower distance or range. It's your phone talking to the satellites. And if you don't know that, you need to look into that. It has nothing to do with cell towers. The accuracy is improved to the point where you can now collect this data very efficiently with cell phones. And when you get back to where you do have Wi-Fi access, you simply hit one button and all of the data you collected automatically goes up to the cloud and gets stored and backed up and could be downloaded anywhere in the world the next day or the next hour. And so there are huge advantages. If you're not using that, then you're behind the times. And I would look into it very quickly. The efficiencies are substantial. The accuracies are substantial. You will not have missing data. You will not have photographs that are sitting around your office and you don't know which site they are of, because everything is linked with these things. So it is the future. I'd strongly look into that. And quite frankly, the older folks who are in the agencies, you need to start listening to and learning from the college kids, because they know this stuff way better than you do. I'll go ahead and stop there. And again, it's been my absolute pleasure to talk today. Please follow up. So Jimmy, is there a way to share that link to the, I've got a Google Drive folder, which is open to anyone with the link. And
Sure.
if you could maybe, oh, it's pasted in already or not?
Yep, we did share it in the
Good.
chat. Dan is sharing it again, and
Right.
so we should be good to go. We will have all these posted as recordings, and I think we can even throw some of these resources on that page too when we do that. And so
Right. Yeah,
thank you, Dr. Marion, for your time. Appreciate this
Yep.
today. Appreciate the engagement, everyone. And we have about 8 minutes till we flip over to our next session. So look forward to seeing some of you in the next one as well.
Okay, real quick, this presentation is also at that Google Drive folder.
Great.
Take care,
Thanks.
everyone. Have a great day and enjoy your holiday weekend.